Okay, so in this little video, what I want to show you is something really critical to understanding how to make statistical types of statements. And really, the question that we're really concerned about is how likely is a particular observation? If we know a distribution, we can actually tell how likely it is. And especially if that distribution is normal, then that's what we're dealing with here. Remember, there's other distributions, but we're going to focus on the normal distribution. So, with that being said, it's all because of the properties of the normal distribution. The likelihood of an event is really pinned down by how many standard deviations away from the mean a particular observation is. And so, with that being said, all we need to do is calculate how many standard deviations away from the mean is this observation. And there's a fancy name for that particular statistic, and it's called a z-score. So here we go. This is your z statistic, and I just wanted to show you exactly, first off, if you were going to calculate how far is this score from the mean, you would just take the particular value, an observed value x, and subtract it from the mean, right? That would tell you how far away it is. That's a measurement right there. That could be positive or negative, and actually, we don't really care at this point. Just for practical purposes, let's just subtract the two. Okay, that's going to be a distance between a value of x on the number line and the mean of x minus the mean. Okay, so a particular value you're interested in looking at, how probable is that value x? Okay, so remember, like when we looked at voting, okay, we said, okay, so we observed that so we took, remember, we went out and say surveyed 100 different people, and then say 67%, and I forgot what number we had in class, say 67% found a favorable rating for say candidate A. Okay, so what's the chance of candidate A having, say, 50% of the vote or less, maybe losing, right? Given that. So you would take the mean. So the x you're interested in is that 50%. And the question really becomes, how many standard deviations is 50% away from that mean? Okay, that's the question right there. And so again, you take 50% minus the mean that you measured of your polling, which is that 67%, whatever you found to be the proportion of people who find favorable for candidate A. Okay, so that's going to be your distance between this between the value that you're curious about, which in this case is 50%, and the mean that you observed. Okay, then all you have to do is divide that number, because that's how far it is. Now the question is, how many standard deviations is that? Well, divide by the standard deviation, or in this case, the standard error. And if it's a proportion, then all you need to know is how to calculate the standard error of a proportion. So look, standard error of a proportion. Okay, so this is actually going to be right up here. Remember, we saw this in class. Forget about that part over there. There's our equation. It's the proportion that we estimated. In this case, I keep forgetting 67%. So it'd be 0.67 times 1 minus 0.67. So what was that? That's going to be 33. So 0.33. So 0.67 times 0.33 divided by, I said, how many do we calculate? How many do we pull? So if we pulled 100, that'd be divided by 100, and you take the square root of that number. That would give you your standard error or standard deviation. In this case, we would just call it standard error, standard deviation. I'm going to say potato, potato, and wave my hands at that. But okay, for this distribution. Now, getting back to the z-score, when I calculate this, so again, how many standard deviations is 50% from 67? That would be 50 minus 0.5 minus 0.67 divided by this standard error that we calculated using this formula right here. Okay, that's going to give you a specific number. That's going to give you a z-score. Okay, the standard z-score. Now, again, When is this going to be, or the interpretation? The interpretation is how many standard deviations are you from the mean with that score? That's what that interpretation is, okay? And it becomes relevant because the normal distribution has very reliable characteristics in terms of its standard deviation. So there's a certain amount of density, or there's a certain area under the curve. Remember, the area under the curve of the distribution is the probability, is actually a probability. So the area between, again, remember, between if you go minus 0.196 standard deviations to the left and plus 1.96 standard deviations to the right, then the area under that curve will be exactly 95% of the area will be under that curve. And you should know that the entire area of the curve is always equal to 1, okay? Because all data is going to be under this particular distribution. It's eventually going to teeter out to nothing, okay? So out in the tails. And so this has very, very predictable predictable probabilities based on the standard deviations. And so that's why we calculate a z-score, because once we know how many standard deviations away it is, we can calculate to a probability and make a probability statement about how likely that particular event was to happen by chance, okay? Because if it's way out in the tails, it becomes more and more unlikely that something like that's going to happen. In this case, unlikely that a candidate might lose, given that you've taken a sample of a population, okay? So, that's a probability statement. Now, I kind of like in class, I was thinking to myself, like, how are we going to find how many standard deviations, and what is it actually like? What was it for? I know it's 1.96 standard deviations for 95% probability. And kind of a question I had on this was just exactly, how many standard deviations is it for just different sort of values, right? Different z values. I got a little confused about this. I thought about it. I was like, why? And I realized, oh yeah, you know what? There's tables about this. So the thing is about where we're at right now is that we're not teaching this with calculus. Okay, so calculus and integral calculus specifically is all about calculating the area under the curve. Now, without calculus, so we could actually calculate some things with calculus and get very specific areas to make probability statements, but you guys don't have it. So what are you going to do? You're going to have to use these tables. I haven't used these tables in a long time, okay? Because once you get calculus and once you start playing with computer programs and they pump out things, you don't even need to calculate anything anymore with those, but you just kind of get away from this stuff. And I kind of was like, okay, I kind of forgot about this. Go back to the basics, I guess. But this is kind of where we need to start, is actually with these z tables. And so with these z values, we can see exactly for a z-score, and you see that the z table, there's going to be several different types of z tables. You're going to have this thing called a negative z-score table, and this is going to give you the probability. So inside these boxes are going to be probabilities. That's what you have inside there. Okay, inside the table are probabilities. Now the z-score is going to be defined. So we're going to the left of the mean. Okay, so how many standard deviations left of the mean? It's going to be this number. So it's going to be, this is actually the first decimal. You see it's negative 0.1. Do you notice that all of these columns are just to a single decimal? Do you notice that? And actually to the second decimal is going to be along the column space. So along the row space, along the rows are to the point, the first decimal place, a z-score to the first decimal place, and the second decimal is going to be determined by the column. So for example, if I went 0.12 standard deviations, okay? To the left, how much area would be to the left of that? That's the question. Well, 0.12. So there's negative. So I'm going negative, right? Because I'm saying everything to the left of this. So this is 0.1. And then 0.12, this is going to be right there. Actually, there's 45% of the curve is 0.12 standard deviations. So if I drew a line, 0.12 standard deviations to the left, and then all area to the left of that is going to be equal to 45%. There's 45% probability that you're going to be 0.12 standard deviations or more to the left of the distribution. And you can actually figure out from this table, you can also figure out the white area, or the area that's not included, by just calculating 1 minus this. So if I wanted to calculate, say, all area to the right of 0.1 standard deviations. So if I went 0.1 standard deviations to the left, somewhere over here, and I wanted to calculate all area to the right of that, all area to this side, I'll go 1 point standard. So I would just do 1 minus 0.45. if we round this to 0.45, then 1 minus that would be actually equal to 50. That's 55% roughly of all that. So if I go to the left, 0.12 standard deviations, and look at all area to the right side of it, it's actually 55% of it is on the right, 45% of it's on the left. That makes sense? It has to add to 1. Okay, so this table tells you that one-sided kind of test, and we can figure that out. Now remember, let's see, we know it's symmetric. So remember, 95%. So if I went, what did I say before? 1.96. So 1.96, there should be 0.25 actually, because remember 0.95 was actually looking at, remember, there's 1.96 was between. So if I go 1.96 standard deviations, I want you to remember this. Looking back at, where are we? Where are we here? So 1.96 standard deviations to the left and right actually gives us 95%. So if I go 1.96 is right here. You see that? That means on the left side, there's only 0.25 or 2.5% of the distribution is off on that tail. And also 2.5 distribution is on the other tail. So that's why we call it a 95% confidence interval, because you end up with 0.25s on both sides. That's actually a two-tailed test. We should actually be a little bit more careful. I'll talk about that in a little bit. But first off, let's just get the concept here. Okay, so we got a z-score, which calculates how many standard deviations are we from the mean. And then we can use that z-score, okay, to then basically calculate probabilities using these tables, because you don't have calculus at your disposal. And the probabilities are in these tables, and the z-score is going to be determined the first digit to the first decimal in the row, second in the column, and we have a negative z-score. And guess what? We also have this positive z-table. This positive z-table is looking at when we go to the right of the distribution, or to the right of the mean. That's what the positive is, okay? So the positive is when we're to the right of the mean. The negative is when we're looking at the area to the left of the mean. We can calculate the probability of this entire area off to the left, and we can also calculate it, the little white area here to the right, by doing 1 minus this probability in this table. So the white probability would be 1 minus the probability in this table. The gray area would just be the number in this table, okay? And again, 1.96 should be 1.96. Oh, actually, this is one-sided. This is truly one-sided. Okay, so 1.96. Yeah. So we've actually got 2.5% off on the tail, on the right side of the tail. That's 1.96 standard deviations. Remember, 2.5 on the right, 2.5 on the left. That gives us a 95% confidence interval. Okay. So again, this is talk about the z-score. It's just the standard deviations from the number of standard deviations from the mean. And it talks about how to read the table, which is kind of like what I just got done talking about. Okay. So, and you can use this actually to calculate the probability. So this can be calculating, again, the probability of a z-score greater than a certain value. So you guys should be able to calculate this probability of a z-score greater than a certain value. Go ahead and practice this a little bit here, and then see if you can't figure it out using those tables. Okay, so let's see. I think this is a good reference. I'm going to put a link to this in Wolfden. You're going to need it probably throughout, so keep a hold of this. I will say this. Okay, there's going to be two tables. I think we'll probably are two tables we're going to need, or you're going to need. You're going to need this z-score table, which is for the normal distribution, and you're also going to need a student t-score, a t-distribution. I'm not going to go into it in detail here. T-distribution is just going to be like a normal distribution. It's just going to have fatter tails is all. Just going to have more probability way out here in the tails, and that's a t-distribution. So you're going to use that, and sometimes a t-distribution. You're going to use a z-table for some distributions, and I'll give you a little. This is a nice thing I found here. I'll give you a link to this page that shows you when to use a t-test and when to use a z-test. It's really just looking at, which distribution are you looking at. Okay, so that's really everything in a nutshell. That's quite a lot that I've dumped on you. Again, the main points are calculate how many standard deviations are you from the mean. Okay, that's going to be your z-score. And then you can use those z-scores to calculate specific probabilities. And you're going to have to frame actually the probability statement according to the problem at hand. Okay, so that's what we're going to have to do. And that's pretty much it. That's pretty much it. We're going to go through this a little bit more extensively. And I know tables, I remember tables being a little bit confusing when I first looked at them. To be frank, once you get calculus under your belt, if you go on with statistics and you actually do statistics, you will never, ever, ever use one of these tables ever. Okay. The only reason that you have to use them is because you don't know how to do calculus. That's really it. Okay. And so the main point is that you know how to use them, because you need to first, I guess the thing is I really care about is that you understand that these are probabilities and you look up the probabilities accordingly. So we are going to use these tables, and I'll give you a link for this. Okay, so that's going to be part of it. So anyway, that was kind of a lot. This chapter is kind of heavy. We're going to be getting through this by the end of this next week. So by then we're going to dedicate about a week to this and hopefully nail it down. And then we're going to go apply some of these concepts to some of the data that we actually have and make some actual data science stuff. We'll return back to data sciences. Okay, that's the plan. Anyway, best of luck. I'll see you in class.